Happy Thursday afternoon. Finishing up. We were looking at the rules last time. Constant multiple, constant power, sum difference, product, quotient. How would you want to attack this? What was that? Conjugate? Well, I mean, you could, but that would make it worse.
And then from the s squared that comes in the denominator, multiply s minus the square root of s by s.
How would that simplify then, using powers?
Not that way yet.
We split that up into two fractions, s over s squared.
Which is what?
Square root of s, right?
S over s squared? Not square root of s.
1 over s.
1 over s, give that to me in the numerator.
S to the negative 1.
Minus what?
Square root of s over s squared.
Which is what?
That's the negative 4.
Not negative 4.
Negative is a half.
Negative 3 halves. Now, isn't that just power rule? Negative s to the minus 2 plus 3 halves s to the minus 5 halves. Factor out a 1 half. That's the minus 5 halves. Factor out a 1 half from negative 1, what are you left with? You factor out, what's the operation? Thought I heard it. Factor 2 out from 4, what do you get? How'd you get it? Factor a 1 half out from negative 1, what do you get? Factoring s to the negative 5 halves out from s to the negative 2. What do you get? What is it? How'd you get a third? So So what's the rule with exponents if you're dividing same base? You subtract them. -2 minus -5 halves. Positive 1/2. Which gives you that. That's why I factored out a 1/2 as well. You could also use quotient rule if you wanted to, which would give you the same thing with more algebra.
So if you were to have this as like a question on the test, what form would you want it in?
What do you mean by form?
Like, how you basically got 3 answers in terms of simplifying, like how simplified would you want it?
You could just use that first one.
Okay.
As a general rule of thumb, you do want to fully simplify and keep it in the original form.
But it would still be acceptable.
How do we have to do this? How would it factor?
The numerator would factor out a t, the denominator would factor to t minus 3, parentheses, t minus 1.
How does that help? It doesn't. It actually makes it worse. Because then you have quotient rule and product rules. Yeah. This is just straight up quotient rule. I believe I went over that notation already. What does the quotient rule say?
Bottom function times the derivative of top function minus top function.
What's the derivative of the numerator?
3t squared plus the minus top function squared.
expand everything out. Do it on a new line. 3t to the 4th plus 3t squared minus 12t cubed minus 12t minus t squared plus 9 minus 2t to the 4th plus 4t cubed minus 6t squared plus t. T to the 4th minus 8t cubed plus 6t squared no t's plus 9. And I'm fairly certain that doesn't simplify.
You have to figure out what's in the box.
Generally, you want your fractions to be in reduced form.
But that's
So yes.
generally.
Up here, I'm 99.999% confident that t squared minus 4t plus 3 is not a factor of the numerator. Call yourself a physics major and you say that's bad.
It's just annoying.
And you call yourself a physics major and you think that's annoying.
I know it's annoying. It's huge.
Just wait till classical mechanics.
I know.
We know.
Because there's worse stuff doesn't mean that's not bad.
Just goes downhill.
Yeah, that's about accurate for physics and math.
Yeah, I feel like so.
You start off at the top of the hill and
You just tumble.
actually tumble may not be right either. You tumble a little bit and then it's just a free fall.
Yeah.
No, there are ledges that you splat on.
Oh, good.
How do you want to do this? No, I assume that means you're a physics major too then. If you're talking about classical mechanics, you must also be a physics major.
No, we're just in the same physics class of engineering.
Couldn't you multiply the two together to start and then do the quotient rule?
Could? So multiply them out, what do you get?
Still for the-
Does it not just simplify to z minus 2 times z plus 1?
Not necessarily. Busy multiplying those together. But
Z squared minus 4 is z plus 2 times z minus 2, isn't it?
What?
Z squared plus z squared minus 4. Isn't that z plus 2 times z minus 2?
That would be.
Isn't there z plus 2 in the denominator?
There it is.
So you're left with z minus 2. Same thing with z squared minus 1.
Maybe I should not have immediately combined those. Yeah, foil them, add them.
So you can FOIL this out, or you can also realize that product rule is really easy. Because the derivative of each of those two terms is just 1. Just get 2z minus 1. Which, by the way, is exactly what you would get if you decided to do the product rule, not simplify, and then use quotient rule, with a lot more algebra. Continuing on, we're going to look at some examples of derivatives being used as a rate of change. What was my second major? Which means most of my exams are going to be physics-based. Obviously, the most common rate of change deals with motion. Specifically, we're going to look strictly at motion along a curve defined by a single variate function. So let S of t be a function giving the position of an object at time t. Velocity is a rate of change. It is the change in position with respect to time. So it would be ds dt. Speed is absolute value. Speed and velocity are not the same thing. Just like distance and displacement are not the same thing. Acceleration is change in velocity with respect to time. So it'd be the derivative of v, right? dv dt. But velocity is a rate of change as well. So acceleration would either be dv dt or the second derivative of s with respect to t.
S. What is S?
Position function.
Right. Thank you. Follow-up question. Why is it not P?
Because p stands for something else in physics.
Right.
If I remember correctly, p is momentum.
Oh, I took physics. Yeah, I think so. I took high school physics, not actual physics.
I would argue that college physics isn't actual physics either.
Right?
No.
Oh.
Kind of like how this isn't really math either. You don't really get exposed to that till junior year. Another common use, population change. P of t is the number of entities present in population. Population growth rate would be dp dt. Changes in cost and revenue. C of x is a cost function. Then we call the rate of change of cost the marginal cost. Same thing with revenue. Rate of change of revenue would be marginal revenue. And then you also have profit. Change in profit is marginal profit. So I may be skipping a round to kind of look at some interesting problems here. So I think I will. I'm going to start by skipping around right now, actually. No, I didn't include it. Oh, that's a shame. I don't feel like second law?
This is the formula one.
Well, that's what I'm asking. What is Newton's second law? Or in differential form.
Force is equal to mass times the differential formula of the velocity.
Is that correct?
That was acceleration. Not velocity.
Well, I'm talking about his law.
I think
When you wrote it in a second.
Well, just in general. Is force mass times acceleration?
Yeah, Newton's second law is correct. I mean, it might not be.
It is not.
It is.
Newton was wrong. He really was. And a thief.
Just like us.
There's the true form. Forces change in momentum.
Momentum doesn't change.
Momentum is defined as mass times velocity. If you take the derivative of that with respect to time, what do you get? So how would you find dp dt?
Do the product of that.
So what would you get?
M derivative of v, which is ds, or ds to
Is that it?
no, because when you do the derivative, so today.
What does m represent? Mass. So what are you told about mass?
It's different from weight.
Well, that's true. Weight's a force. An object's mass, does it change over time?
That wouldn't matter.
So then dm dt would be 0.
Yeah.
So that would give you m times acceleration, right? But Newton was wrong. Because you just made a fatal assumption. You assumed mass is constant. It's not.
Why isn't it constant?
Ever heard of someone called Einstein
You want me to?
and his theory of relativity? Mass is a function of your speed. The faster you move, the more mass you have. Specifically, That's the equation for mass.
So we need that equation. Because I think that's the speed of light at the bottom there, right?
So m naught is your rest mass. So that is what you would typically think of as mass being constant. C is speed of light.
I don't have that memorized.
And v is obviously speed. Now, for very slow speeds, v squared over c squared is negligible. So the denominator is essentially just the square root of 1, which would then make mass your rest mass, hence it's constant, thus you get F equals ma. However, if you are moving close to the speed of light, mass is no longer constant. You cannot assume constant mass. This is why you actually can't move at the speed of light. Any object with mass cannot move at the speed of light. Otherwise, it would have to gain infinite mass for E equals mc squared to balance. Speed is a function of time, of course, which means that mass is a function of time. So that's why the correct form is change in momentum. Just one of the many, many things that you were taught true. That was a lie. Time is also not the same for everyone. Time depends on your reference frame. Next one I want to do actually has to do with Newton again. Newton's law of gravity. States that the magnitude F of the force exerted by a body of mass m on a body of mass big M is given by G times big M times little m over R squared. G is the universal gravitational constant. R is the distance between the bodies. So what this says is that every body with mass exerts a gravitational pull on every other body of mass. Sadly, once again, Newton was wrong. This is actually not correct. But it does work for small enough masses. Remember the equation I showed you on day one? Einstein's field equations? That is the actual law of gravity. But that is really advanced. So that we won't ever get into. Right. Again, this means the further away you get from an object, the less the force of gravity. So we're told that Earth attracts an object with a force that decreases at the rate of 2 Newton per kilometer when R is 20,000 kilometers. How fast does this change when R is 10,000? So we're dealing with rate of change, which means we want derivative. What is df/dr? Again, we're working in Newtonian reference frames, which means the relativistic effects on mass are negligible, so treat mass as constant. So what would df/dr be? This is a simple derivative. So G is constant, right? Big M is constant. Little m is constant. So that's a scalar. So it's a scalar times 1 over r squared. Scalar multiple rule. So we just want the derivative of 1 over r squared. What's the power of r? So what's the derivative of 1 over r squared?
-2 or to the negative third power.
So that is how the force of gravity changes with respect to distance. Of course, this says that as you get further away, the distance is decreasing proportional to 1 over r cubed. Right, proportional to the reciprocal of the cube of the distance that you increase. We need to find the constant GMM. What do we know? We know that rate of change when r is 20,000 kilometers is 2 Newton per kilometer. Which has to equal 20,000 cubic kilometer, or has to equal -2 GM little m all over 20,000 cubic kilometers. 20,000 cubed cubic kilometers. Divide by -2. Oh, sorry. decreases at a rate, so that should be -2 Newton per kilometer. Should we make that +1? There's our constant. 20,000 cubic kilometers. By the way, that would mean that these two objects are really massive. Because G is very tiny. G is a magnitude of 10 to the minus 11. So these are massive objects. Don't even know if Newton's laws would work with these masses, but we're just going to and move on with our life. Now we know the constant, we can find what the rate of change is at 10,000 kilometers. What is 20,000 cubed divided by 10,000 cubed?
That's 8. That's 8.
How'd you get it?
Threw that in the calculator.
That makes me sad. You don't need a calculator for it. Remember, not most want to buy the 2 yet. 20,000 over 10,000 is what? 2 cubed is 8. So 20,000 cubed over 10,000 cubed is 8. Without a calculator. And then times -2. -16, what are the units? Newton per kilometer. What does this mean?
That's our instantaneous rate of change.
This means that when the objects have a distance of 10,000 kilometers between them, each kilometer increase in that distance will decrease the force of gravity by 16 newtons. However, you cannot use this to say, if I go from 12,000 to 13,000 kilometers, then that would be -16 times 1,000. So that's not how that would work.
Your rate of change is still changing.
You have to be close to 10,000 in order for this to be true. Right, so I could do something like from 10,010 to 10,015. Then we can say it's approximately a decrease of 5 times 16.
At that point, didn't we just use the original formula to calculate the exact force, assuming we're going by Newton's rules?
You could.
Right.
this one next. No, I think I'll go back. Current is essentially just a flow. It's a rate of flow. Specifically, it's a rate of flow of charge. So whenever you have a flow of charge, you have current. The quantity of charge is given by Q. Standard unit is the coulomb. So let's say we have a quantity of charge passing through a point at time t is given by t cubed minus 2t squared plus 6t plus 2. We want to find the current. First, what do we think current is represented with? Right, if charge, so charge is capital Q. What would current be?
Lowercase q.
QT over,
It's definitely a rate of change, but we give it a symbol.
Uppercase L.
L?
Specifically uppercase.
L is something else. L is inductance. Current is capital I. I don't know why. I just know that it is. And yes, that would be dq dt. So what would the equation be for current?
3t squared minus 4t plus 6.
What would it be measured in?
Coulombs.
Coulombs per second.
Be coulombs per second, but that is a special unit.
is it under case
Right, so I will write it is technically coulombs per second, but we call that something. Just like the Newton is technically kilograms meters per second, but we give it a special name, the Newton. We give coulomb per second a name.
Watt or amp or something you've heard of before?
Hmm?
Is this like watt or amp or something you've heard of before?
It's one of those two. Which one? Amps.
Alright.
It's the ampere or the amp.
So it's just coulombs, is that watts?
No. Watt is for intensity.
Okay.
Right, so lights are measured in watts for their intensity. The hell, where did that VER come from? I think that's supposed to be vertically upwards, so why did it not finish that? That's going to be annoying. We'll have to... I'm not changing on every slide because there are multiple slides with it. So that ver, we're just going to assume is shorthand for vertical. Height of a projectile shot vertically upward from a point 2 meters above ground level with an initial velocity of 24.5 meters per second is given by 2 plus 24.5 t minus 4.9 t squared. T being measured in seconds. So 2 things here. 1, the fact that it's being shot vertically is important. If it wasn't vertically, then this would be a Calc 3 problem, because you need vectors. Vertically means we're only dealing with 1 dimension, so that's Calc 1. 2, there is another huge assumption that's being made here.
We're on a plane.
Rubber.
Gravity.
Unless you're in space.
Gravity exists in space too.
Not as much.
Air resistance is negligible.
Friction is negligible. So we're assuming there's no drag. There are 2 scenarios for this. 1, this is being done in a perfect vacuum, which again, there's no such thing as a perfect vacuum. Even space, believe it or not, has resistance. It's just very, 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 very slight. Or the surface area of the object is extremely small, because friction is a function of surface area. So, a good example would be a bullet. Bullet actually has negligible air resistance on it, which is nice. This could be like a tiny marble. Right? So, I'm going to go with, we somehow came up with a very tiny cannon that can shoot a marble at that speed without breaking it. Let's go with that. Find the velocity after 2 seconds and after 4 seconds. First, what's velocity? Derivative. It's derivative of h with respect to what? Right. Whenever you take a derivative, you have to say it with respect to what? It's a dot. It's dot notation. So what is the derivative of height with respect to time?
DHDT.
Which is what?
Negative 9.8 T plus 24.5.
After 2 seconds, what do you get?
Meters per second.
What about after 4 seconds?
And force 0.7.
What does that negative signify?
It's going down.
Right? Fraction. Right, so what you would say is position is decreasing. That's what the velocity being negative means. So the height would be decreasing instead of increasing. When does the projectile reach its maximum height?
That's velocity is zero.
Careful. So aim is velocity zero. You would remember about 3 seconds.
Wait.
The first time you change velocity is
Because theoretically, at the start, before it's launched, velocity is zero. And that's not its maximum height.
the second time it's zero.
So that's why I said be careful.
We don't need.
And when it hits the ground again, the velocity becomes zero,
Yes.
which means it's not maximum height.
Its maximum height is when it's real rise.
But yeah, we're gonna just take it to be v of t equals 0 and see what we get. So we said v was what? 24.5 minus 9.8 t. So that has to equal 0, which means t is what? $24.5 over 9.8.
Two
2.5 what?
meters. Oh, when? This is when? Oh, we're doing where?
Seconds. So about 2.5 seconds after launch is when it reaches its maximum height. What is the maximum height?
You plug in the time it takes to get the top of the original equation.
What does that give you? Come on, you can't do that in your head. Yeah. Obviously about 32. So about 32. $32.625 what?
Meters.
When does it hit the ground? How do you get 5 seconds?
Because it took 2.5 seconds to reach the top.
But
It would be falling at the stand right there.
But it started.
Did I say that it's starting at the ground?
It started 2 meters.
It started.
So.
Oh, it started 2 meters above it, right?
So
Okay.
I want to know how.
I wasn't thinking properly.
So how would you determine it?
We either add the 2 or subtract it. We do one of those.
You're overthinking this. When it hits the ground, what is its height? So just solve that for t. Menu, algebra, solve. Type in the equation, solve with respect to what? So, when does it hit the ground?
About 5.08 seconds later.
Why is it that one?
If we didn't go into the task, we could use the other one.
Time can't be negative. Actually, that's also a lie. But again, we'll
Not negative.
not consider that for this course. You actually can have negative time if that's
That's more Einstein.
that's advanced. So it takes about 5.08 seconds to hit the ground. So you were close. You're off by a fraction of a second, which unfortunately could be life or death. So, because if you're off by a if your calculator's off by a fraction, and you get too close to a black hole, you're dead. There's no escape.
When you're getting that close to a black hole, you're asking for trouble.
No, there is a safe point.
Yeah.
The event horizon, the Schwarzschild radius. That is the distance of no return.
Well, hold on.
But you can get right up to it as long as you don't actually hit the radius. You're fine.
Well, question, how big is it?
Doesn't matter. Every black hole has a Schwarzschild radius.
Yes, yes.
Well, that's what I mean. If your calculation's off by a fraction, it doesn't matter the size of the black hole.
Is this, are we looking at an interstellar black hole where it has all that consciousness going around this?
Every black hole does. It's just not visible.
I thought that was only for each one.
I mean, technically speaking, but black holes are always feeding unless there's nothing near it. But I believe they still emit radiation. You just can't see it without instruments. With what velocity is it going to hit the ground? So what would we do? What did we say velocity was? 24.5 minus 9.8. What is that? About 25, about negative 25.28 meters per second. What does little g represent?
Approximation for the force of gravity equal on Earth's surface.
Not the force. That's your weight. Right? Little g is acceleration due to gravity on Earth. What is it approximated as? 9.8 meters per second. We always do negative g to keep g positive.
So positive g equal to negative.
So little g we take as 9.8. And then we just say minus g to represent that it's
Oh.
downwards. They keep G as positive. Is that constant? Nope. Gravity is a function of distance, which means the acceleration is going to decrease the further away you get from the Earth. Another thought experiment. Say you're in a perfect vacuum. You drop a feather and a bowling ball at the exact same time. Which one hits the ground first? They were both hit at the same time because there's no air resistance.
So they did that on the moon one time.
Yeah, I think there's still a little bit of air resistance on the moon now.
I actually saw the video. They hit the ground at practically the same time.
Yeah, because it's negligible.
Yeah.
It is interesting, but again, air resistance is always a thing, sadly.
But you can hear the guy on the phone saying,
What?
About that.
What weighs more, a ton of bricks or a ton of feathers? They're both the same. It's just you're going to need a lot more feathers. How many accelerators does your car have? There's a number.
Fords, the wheels, they do the spinning.
You're on the right track.
2 per week. 3 per week.
3. Gas pedal, brake pedal, and your steering wheel. Velocity has a direction. If you turn, you're changing the direction of velocity, hence you have acceleration. Don't forget, the quiz is due before the start of Monday's class. Your first exam is Monday. Make sure that you bring in a pencil or black ink pen. It will be open note. If your notes are electronic, you can use the electronic notes. Your device must be on airplane mode. And I will be randomly checking throughout the period to make sure that's on airplane mode. If I see it not on airplane mode, it's an automatic 0.
Can I print out the slides?
You can. Yep.
And just
Slides count as notes.
I just staple them all together.
See you then.